All right, let's look at the homework 10.4, problem number 9. All right, so we want to find the exact length of the curve. Use the graph to determine the parameter interval. All right, so I'm going to use GeoGebra here. Here. All right, so let's see. First, I'm going to define the function. I'm going to use t instead of theta. It's easier to type. So you have a cosine squared of t over 2. Right, so hit enter. Right, we don't have to see the picture of that. Right, and I'm gonna put a slider, and let's see, I'm gonna call it b, and from 0 to, say, I don't maybe up to a 4 pi or something. Actually, I don't think we need it 2 pi. How about that? Actually, let's do 4 pi just in case. Right, then increment, I don't know, whatever. All right, so we have that. Then we're gonna draw a curve. Right, so curve. Then first is just r of t cosine of t. Then you have r of t times sine of t. All right, then parameter is t, and going from 0 to, say, b. All right. So here's the picture. All right. So I'm gonna, this is the ending number. So if I increase the ending number, you can see that the curve is gonna extend. So this is around probably 3.14. This is about pi. Right? Then you have gonna complete it. So you can see that completes the cycle around 2 pi. So it's gonna go from 0 to 2 pi to complete it. All right, so now we know what it is. All right, so let's compute this. All right, so first we have to take the derivative. So r prime, or dr over d theta would be, all right, so put 2 in front, and cosine of theta over 2 times the derivative of cosine is negative sine, so I'm going to put the negative sine of theta over 2, then multiply by derivative of inside, which is 1/2. All right, so we can cancel 2 in front on top and the 2 on the bottom. So this is going to be equal to negative cosine of theta over 2 times sine of theta over 2. All right, so we got that. All right, then let's compute square root of r squared plus dr over d theta squared. All right, so this is going to be, there's a big square root. All right, so r squared would be, it's cosine square over d, so it's going to be cosine to the 4th power theta over 2 plus dl over the theta squared. So negative sign is gone, so you have a cosine squared of theta over 2 and the sine squared of theta over 2. All right, then we can simplify this. All right, so if you pull out the cosine square, so cosine squared, because that's a common factor, right? Then you're left with cosine squared of theta over 2 plus sine squared of theta over 2. And then we take the square root. All right, and you can see that here cosine squared plus sine squared, that's going to be equal to 1. All right, then square root and square cancel out, so you basically get cosine of theta over 2. All right, Then all you have to do to find the length, the arc length, so I'm going to call it L is equal to, all right, so it's going to be an integral, all right, from 0 to 2 pi. But what I'm going to do is I'm going to just do 0 to pi, then multiply by 2, because using the symmetry. So it's going to be, I'm going to use pi here and multiply by 2. So you have a cosine of theta over 2. And the theta, so this is going to be, all right, find the antiderivative. So antiderivative cosine is sine of theta over 2, and you have to divide by 1/2. So switch the same thing as multiply by 2. All right, then you're going from 0 to pi. All right, so this is going to be, let's see, 2 times 2. So I'm going to just put 4 outside. All right, and plug in pi. So sine of pi over 2 is 1 minus sine of 0 is 0. All right, so the length is going to be simply 4. All right, so let's type it in. So answer here is 4. All right, submit for testing. All right, it came back, and that looks like we got this one correctly. All right, that's it. I hope that this was clear.